Okay, so we have a physics PhD qualifying exam practice problem. This is number 9, and electromagnetism. We'll go through this rather quickly. You have this as a reference. A grounded conducting spherical shell of radius r is centered at the origin. A point charge q is placed at position r naught equals d z hat, where d is less than r, inside the shell. Part A, construct the Green's function satisfying del squared g of r comma r prime equals 4 pi delta times quantity r minus r prime with boundary condition g of r comma theta comma phi equals 0, or phi. Some pronounce it phi, some pronounce it phi. For part B, determine the electrostatic potential everywhere inside the cavity. Part C, calculate the induced surface charge density sigma of theta on the conductor. And for part D, determine the force acting on the point charge. So Green's function and electrostatic boundary value problem. So we might just switch A and B here. So for a charge q at dz hat inside a grounded sphere of radius r, use the image charge method. The image charge is q prime equals negative q r over d, located at d prime equals r squared over d on the z-axis outside the sphere. So the potential inside the sphere is as follows. Okay. And well, we could say here, this is valid for r is less than capital R. And at r equals capital R, the two terms cancel exactly. So here we have this phi r theta equals 0. Therefore, the conductor is grounded. So the Green's function here is going to be g of r comma r prime equals 1 over absolute value r minus r prime minus capital R over r prime times this 1 over absolute value r minus capital R squared over r prime squared times that r prime. And this is where r prime is less than capital R, and it satisfies this del squared g equals negative 4 pi delta r minus r prime. And our g of r comma r prime equals 0. And following this, the surface charge density is found from the sigma of theta equals epsilon naught e sub r comma theta, and that equals negative epsilon naught, and this is that partial phi, d partial phi with respect to r, where r is r minus. So then our sigma of theta, that equals the following: negative q over 4 pi r times capital R squared minus d squared over this quantity, capital R squared plus d squared minus 2rd cosine theta, that quantity raised to the 3 halves. Raised to the 3 halves. And this is negative everywhere for q is greater than 0. Okay. Now from here, let's do this second part. Actually, fourth part, the force. Determine the force acting on the point charge. So we could say here the force on the real charge. Sorry about that. So we could say here the force on the real charge is the force from the image charge alone. The distance between the real and the image charges is d prime minus d equals r squared over d minus d equals this quotient here, r squared minus d squared over d. Okay. And let me just take this off here. Sorry about that. And here f is equal to 1 over 4 pi epsilon naught times this quantity, absolute value of q prime, over this quantity d prime minus d squared. If we substitute this absolute value of q prime, that equals q times r over d. Then f is 1 over 4 pi epsilon naught times q squared capital R over d over quantity r squared minus d squared squared over d squared. And that equals 1 over 4 pi epsilon naught times this q squared r d over quantity r squared minus d squared squared. So we could say the image charge is outside the sphere on the positive z hat side, so the force is attractive towards positive z hat. So our force is 1 over 4 pi epsilon naught times q squared rd over quantity r squared minus d squared squared z hat. All right, so we just went through that quickly. You have it as a reference. Sorry if I miscommunicated anything. I know I went through this fast, but thank you very much and have a great day.